Consider this. You wake up in the morning, make your coffee, and start your day. Everything seems perfectly ordinary. But did that little decision you made that morning, taking a different route to work, sending that message or not sending it, accepting or rejecting that opportunity, actually lead you to a different life? Or was that life already there, waiting for you? It's easy to ignore this question. But before you do, consider this. What if physics tells us exactly that? That is, if physics truly tells us, through equations and experiments, that the universe first traces all possible paths, then focuses on one, then this question is no longer philosophy. The world we grew up in taught us that objects follow certain paths. A ball is thrown into the air, traces a certain curve, and falls to the ground. Planets orbiting the sun follow their orbits precisely. Everything has a path. That path seems predetermined, and you are a small but fixed part of this big picture. They call it Newtonian world, a world where everything is separate, independent, and predictable. But at the turn of the century, this world began to shake in an unexpected direction. In Germany, a simple engineering question about the then newly emerging electric light bulbs opened the door to a discovery that overturned the foundations of physics. Scientists were trying to understand what colors of light a hot filament emitted. A simple question, but the answer was far from simple. According to the theory accepted by everyone until then, the higher the frequency of the light emitted by an object, the more energy it expended, and this would continue indefinitely. On paper, it was consistent, but in reality, it wasn't. Experimental data showed that at high frequencies, energy began to drop at a certain point. The theory couldn't explain this drop, and moreover, it was absurd in itself because it predicted infinite energy. They called it the ultraviolet catastrophe. A nice name, isn't it? The self-destruction of physics, not philosophy. Max Planck solved this problem, but he was so uncomfortable with the method he used that he almost didn't want to publish it. What he did was this. He assumed that energy was not a continuous flow. That is, it could not be divided into as many small particles as you wanted. Energy arrived in specific packets. He called each of these packets a quantum. And the size of a quantum was directly proportional to its frequency. This meant that at high frequencies, the energy packet was so large that the vast majority of atoms didn't have enough energy to comprise it. Therefore, the spectrum peaked and then dropped. The formula perfectly matched the experiment. Planck published it, but he was uncomfortable with it. It was just a mathematical trick, not a real explanation. He didn't know what the constant he called h meant. Years later, when you look at the units of this constant, you see something interesting. Units of action. Mass multiplied by velocity multiplied by distance. This quantity, called action in the world of physics, was a useful but not well understood tool used to solve problems until then. Planck's constant indicated that this action was the smallest unit in nature. Then Einstein came along. He said that what Planck had found was not a mathematical trick, but an explanation of reality. Light did indeed arrive in packets. These packets were called photons. Niels Bohr applied this to atomic structure and explained why electrons orbit the nucleus in specific paths. The pieces were beginning to fit together, but the big picture was still missing. The piece that completed the big picture came from a French doctoral student. Louis de Broglie asked, "If light is both a wave and a particle, Couldn't matter particles be too? He suggested that electrons, even basketballs, even people, have wavelengths. This seemed absurd at first, but the math was correct. And once that was accepted, everything made sense. Because a wave doesn't exist at a single point. It propagates. It occupies everywhere at once. And if an electron is truly a wave, that is, if when you take it from one place to another, there are not just one path, but all possible paths, then the story physics has been telling up to that point is incomplete. The particle is not in a single place before observation. It exists in all places, simultaneously, as a cloud of probabilities. Richard Feynman later devised a thought experiment that most clearly demonstrated this. The story goes like this. A professor was explaining the double-slit experiment in class. You passed electrons through a screen with 2 holes in it, and the electron behaved as if it had passed through both. A student asked, "What happens if we open a 3rd hole?" The professor replied, "Then you would have accounted for all 3 paths." The student continued, 4, 5, 6 holes? The professor was beginning to get angry, but the student was unstoppable. What if we make an infinite number of holes, and then replace the screen with a vacuum, and then an infinite screen? To the professor, this student was Feynman, but whether real or fictional, his logic was flawless. Because if you accept this, that is, if you can't tell which hole the particle goes through, if you have to account for both, then even without a screen, even just moving in a vacuum, the particle is simultaneously traversing all possible paths, including those going faster than the speed of light, including those going to the moon and back, including those going back in time. They are all accounted for. So why does everything seem so orderly? Why does a ball move along a certain curve and not everywhere like an indistinct cloud? The answer lies in how these paths interact with each other. Each path has a phase, just as a wave has a phase at a particular point in time. When these phases are added together, the phases of very different paths cancel each other out. This is called destructive interference. However, paths that are very close to each other, especially those requiring least action, reinforce each other. It's constructive interference. And this converging path is precisely the trajectory we see. Therefore, the ball doesn't follow a particular curve because it's programmed to. This curve is the result of the vast majority of infinite possibilities coming together and canceling each other out. The orbits of planets, the stability of atoms, the reflection of light, all are explained by the same principle. Everything is first tried everywhere, then only the consistent ones remain. This experiment demonstrated this. If you take a mirror and block the point where light normally reflects, the light disappears. However, if you block certain sections on either side of that point in a particular order, so that the phases of the remaining sections reinforce each other, the light begins to reflect from unexpected angles. Light shouldn't reflect from there because, according to normal rules, that path didn't exist. But when the phase of that path aligns with the others, it appears. Light was already trying that path all along. It's just that until that day, the other paths were silencing it. Now, we need to stop here and take a step back, because what this physics describes reminds us of something much older. Centuries ago, in a time when the scientific method had not yet taken this form, some ideas said, reality is not static. How you approach it shapes it. What is above is below. What is inside is outside. These sound like mystical words, but the language of quantum physics bears a strange resemblance to them. In the classical Newtonian world, you and the universe are separate. The universe is a machine that operates independently of you, according to fixed rules, and you are a small cog in that machine. But in the quantum world, this clarity disappears. You cannot tell where a particle is without measuring it. Observation concretizes probability. The boundary between the observed and the observer is not so sharp. At this point, some people go too far and interpret physics to suit their own purposes. Statements like, "You can create anything with your thoughts," stem from this, but mostly they distort physics. However, there is something truly striking in the picture that physics presents. Probability is not concrete before it happens. Which path becomes visible depends on how the paths reinforce and weaken each other. And this reinforcement is not imposed from the outside. It stems from the consistency within the system itself. Something similar seems to be happening in people's lives. This time, not with equations, but with behaviors. A large part of the probabilities in a person's life depend on where that person directs their attention, what situation they accept as real, and how they define themselves. This is something that psychology says and neuroscience supports. Your brain is programmed to see what you pay attention to. When you focus on what is absent, the brain scans for what is absent while pushing what is present into the background. There is a concrete example of this. Someone describes living with a feeling of being stuck for years. They lived in a building with a free gym, but they never went. Opportunities were all around them, but they couldn't see them. It wasn't the outside world that changed. It was the internal assumption that changed. When you begin to see yourself not as someone trapped, but as someone free, the things around you, things that have always been there, suddenly become visible. It's as if you've taken a different path in the same world, like the diamond fields of angels. Why do you stand on them when you can't see the diamonds? This isn't a coincidence. This is how the mind works. You carry an assumption about yourself, and this assumption largely filters your world. Someone who feels powerful and someone who feels crushed see different things in the same room, in front of the same opportunities. This isn't metaphorical, it's neurologically true. Attention works selectively, and assumptions determine the attention filter. Quantum physics tells us that everything first tries all paths, then only consistent paths remain. A similar situation occurs in the human mind. Initially, all interpretations are possible, but the mind's search for consistency eventually settles into a particular narrative. And once this narrative is established, you begin to scan the environment according to that narrative. As if you've entered that path, other paths gradually become invisible. But the beauty of it is this: it's not permanent, it's variable. As Planck said, sometimes you have to be prepared to abandon old beliefs. When you're completely stuck, when you need to think differently, sometimes the most unexpected things come up. Planck struggled with the black body problem for years, and even when he found the solution, he didn't want to believe in his own solution, because it didn't make sense within the framework he was used to. That student of Feynman thought the same way. While everyone was happy with 2 slits, he asked, "What about infinity?" This seemingly absurd question revealed one of the deepest truths of physics. Everything is already trying every path. We couldn't see it because what we could observe were the remnants of paths that erased each other. And perhaps this tells us that there is a great difference between what is visible and what is possible. What is visible is what has already gained consistency, but behind this consistency lies countless possibilities silently erasing each other. Just because you can't see something doesn't mean it hasn't been tried. It just means it hasn't yet condensed. The understanding of physics is taught historically, and that's why most people spend their lives without ever hearing the principle of least action. Yet when you ask a theoretical physicist what they're working on, they're not talking about forces or energy, but about action. Because when you write down action correctly, the laws of physics emerge spontaneously. Not separate rules, but a single mathematical framework. Perhaps this metaphor is broad, perhaps not entirely accurate, but one inevitably thinks, if particles concentrate least along the path of action, then people also concentrate, in a way, along the path of what they believe. What you expend your energy on, what you accept as true, what assumptions you make about yourself, largely determines what is visible and invisible to you. This doesn't make you the master of everything. Physics doesn't make you that either. But it does say this: the result of a system stems from the consistency within the system. And some of that consistency is carried by you, even if you're unaware of it. Does light know every path before it goes? No. It only tries. And in the end, only those that are consistent remain. Perhaps the question is, what does what is consistent for you really say?